Alrighty, everybody, welcome back to our second video for this week and talking about and continue our conversation of sustainable agriculture and raising crops. So the next bit that I kind of want to touch in on here is talking about soil and the importance of soil and its role in agriculture and perhaps ways that soil's not doing so well at the moment, and ways that we can maybe help soil kind of do a bit better, if that makes sense. If you're watching this for the spring 2024 semester, I know several of us had mentioned that soil and soil health is something that's actually pretty important to them in terms of an environmental concern. So this section's for you. We could go on for much longer than I'm sure I'm going to blabber on about in terms of soils, but this is kind of just dipping our toes into this idea of soil. So some things that I want to mention initially with soils are that it's a much more complex living ecosystem of minerals and organic materials than maybe we would think of with soils. You think of soil maybe just like dirt, like you're out on a playground or something, you're out at a park and it's just the dirt that's there. Maybe you don't consider everything else that's allowing for this dirt to be there, and maybe where that dirt even came from, especially if it's there naturally. But soils are made up of a complex of bacteria, invertebrates like worms, and snails and fungi. So fungus are a huge thing here that helps support the growth of plants. So it's this mutualistic relationship between these various organisms and various species that allow for growth of other plants and plant materials. I also want to mention, and maybe you know this if you were someone who maybe got into plants during the pandemic. I know a lot of people got really into plants during that time. And you know then that certain plants love certain soils or need certain levels of pH or need to get watered at a certain time. Or if you have a variety of cactus or succulents versus monsteras or whatever. I'm sorry if I pronounced that incorrectly, but different plants need different things. Yeah. So knowing what those different varieties need will be helpful in terms of growing what you want to grow, whether or not that's flowers or crops or, cactus, whatever it is. The soil content matters. And it also can impact what your crop tastes like if you are planting something that is going to be consumed by humans. For example, and a big example of this for me anyway, I love wine. I'm a wino. I have several wine memberships. I go up to Napa relatively frequently, and I love learning about the intricacies that various vineyards have. So a lot of Napa in particular is a lot of volcanic clay, because we're old volcanic island arcs. And so the use of that clay and the use of that mineral and material changes how wines can taste, and it can change their effervescence sometimes, and their depth of flavor. Of course, there's way more things going into winemaking than just what the soils are like, but if you're starting at the base, you're starting at the root, if you will, of where these products are coming from, then you're going to draw in that flavor, or you're going to draw in those characteristics, which is really, really fascinating. So that's why wines can vary from region to region, even from the San Lucia Mountains versus the Livermore Hills. There's huge differences there in the soil makeup, which can in turn change the wine. Anyways, another very, very important thing about soil is it's a large carbon sink, and relatively instant carbon sink. The oceans are actually our number one carbon sink. I do want to mention that. But soils and our earth do a very big job of taking in carbon. Think about this one for a second. Where is that carbon coming from? How are we getting this carbon from, the atmosphere into the soils? I want you to pause the video perhaps and give it a thought before I give you the answer. But it's essentially, what is the process that plants go through? What are they doing for us every single day? They're taking in ultraviolet light and carbon dioxide and producing oxygen and sugar for us, right? So, in that process of taking in carbon dioxide, intaking carbon, it's storing that not only in its own like leaves and stems and what have you, but it's also storing it into the soil and allowing for carbon capture to occur there. So it's a really, really, really important aspect. Soils also play a large role in groundwater quality. If you recall from our videos from last week and the week before, looking at groundwater and freshwater quality, groundwater is a really nice like filter, right? You could literally make a natural filter out of various rocks and soils, going from dirty water to clean water in like 2 water bottles. It's actually really fascinating to look at. So that's really interesting too. So if you have a bad topsoil, you're probably not going to have good groundwater quality. And unfortunately, at the moment, our soil health is heavily at risk. And that's not great. And this is due to erosion, but also nutrient depletion in our topsoils. So what I want you to do, make sure when you're reading this module of the book that you study this infographic carefully, and just know that there are different levels and different layers of soils, and what they call them different horizons is the technical term for soils. So the 2 top layers, the surface litter or 0 horizon and A horizon, that's considered the topsoil. And this contains the decaying organic matter and living soil organisms. What I also want you to notice in this schematic is where the roots kind of continue, where most of them are, and then where they stop. So the C horizon is where there's rocks, and which is being broken down through the process of weathering to produce new soil. And solid rock has not been broken down in the R horizon. And this varies, of course, from location to location, region to region, soil type to soil type. But just wanted to mention that here. So the best, so roots can pass through looser soils much more easily, but they do not offer good structure to support plants, right? So you want to have like a combination of larger particles and smaller particles and medium-sized particles so that roots come down really nicely, but are also secured within that space. If you're from California and you've gone through any of these heavy wind events that we've had in the past couple of years, that's this is a larger scale idea of this, but it's like some of the root systems here in California are pretty shallow for some of the trees. And so when you have big wind events and the roots aren't going down far enough, then you're going to have a lot of trees topple over more easily, things like that. Whereas trees in the Midwest, those trees are more adapted to a lot of wind, and so the roots will go down farther, but also maybe the soils are more apt for roots to go down farther. Whereas here, there's a lot of clay. So anyways, some interesting kind of analogies or anecdotal evidence to kind of help hammer in those ideas. And then, so we have some issues going on with soil. A big one being soil erosion. So soil formation in and of itself is an extraordinarily long process. It takes, a study estimates that it takes, in most places, it takes 500 to more than 1,000 years to generate 1 inch of soil that is precious for food growth. And you'll read that statistic in your book. I highlighted it. I thought that was really wild. And so it takes a long time for it to be what it is. And we are eroding it away at an astronomically fast pace. And so this includes, of course, the weathering of rocks and decomp of organic material. Something that my dad does to help with soil erosion on his farms is uses things called sediment basins that can help control water flow a bit easier. It's kind of like a river dam, but for soil. And it's in like a sort of a ditch area with a tube. And so it's just really trying to control this whole region and space of soil. Then he can take those soils and kind of put them back to where they were. as opposed to just like letting them just go on and on off into someone else's property or someone else's farm. He's able to recollect it and kind of put it, in a sense, put it back to where it came from. So going back to the idea of industrial farming and what can happen with that. So a study has estimated that as much as 5 tons of topsoil, so that fertile region of soil, is lost for every 1 ton of industrially produced grain in the United States, which is a staggering statistic, right? So 5 tons of topsoil are eroded, are lost, gone for every 1 ton of industrially produced grain. So we're losing way more than what we are even producing, right? So that is what is the literal definition of unsustainable, right? So how can we fix this? What are new methods that we can do to help assist in soil health, in farming health, and making things more sustainable? Check back in the next video and you will get your answers there. Thanks so much for watching.